Now, if trigonometry says that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent, what that is telling us is that when I type in sine of 20 degrees into my calculator, that means I can draw a triangle anywhere with 20 degrees. So if I pick a random point here and go straight down and draw this right angle triangle with 20 degrees, if I measured the opposite side and I measured the hypotenuse and I divided the opposite side divided by the hypotenuse, I will always get 0.342, no matter how big or how small I draw that triangle. Now in grade 10 and grade 9 trigonometry, triangles were obviously triangles, and triangles always were angles that add up to 180 degrees. So the question is, once you move into quadrant 2, quadrant 3, and quadrant 4, how is it possible to still do SOHCAHTOA? Because SOHCAHTOA only works with an angle that's 90 degrees. And if the other angle is 160, all of a sudden I'm like, wait a minute, 90 and 160, that's 250 degrees. No triangle is possible. How do we do trigonometry when we go beyond 90 degrees? Well, we still pick any random point on our terminal arm. We go back to the nearest x-axis, which includes our reference angle of 20 degrees. And an interesting thing happens. Sine of 160 degrees, well, I'll do the same. I'll color code it just like we had before in green. Sine of 160 degrees is still 0.342. But now cos of 160 degrees, the numbers stay the same, but it is now negative. And tan of 160 degrees, the numbers stay the same, but it is also now negative. And only sine stayed positive. We're going to see a little bit of why that happens in grade 12 pre-calculus. But in grade 11, when we saw this happen, this is the start of what we call the cast rule. Okay, we'll write down sine, cos, and tan. Same thing happens for 200 degrees. Pick a random point, draw it up here. That would create a right angle triangle with your reference angle of 20 degrees. And sure enough, sine of 200, cos of 200, and tan of 200 have the same numbers, but now sine is negative, cos is negative, and tan is positive again. And finally, when we did 340 degrees, the numbers will be the same because you pick a random point, go back to your nearest x-axis, which makes a triangle with your reference angle. And we would have negative 0.342. We would have cos of 340 degrees being positive 0.940. And tan of 340 degrees being negative again. This is how trigonometry works beyond 180 degrees. Two things are involved. The reference angle is really important because the reference angle makes the answer the same as the regular one in quadrant 1. But now positives and negatives change, and we can remember positives and negatives with the cast rule. The cast rule says A for all of them. Basically, the cast rule, put a positive sign above it, because the cast rule is just where things are positive. All of them are positive in quadrant 1. When you get to quadrant 2, did you notice that the only one that was positive was sine? That's not quadrant 2. Let me circle up here. There we go. The only one that was positive in quadrant 2 was sine. The only one that was positive in quadrant 3 was tangent. And the only one positive in quadrant 4 was cosine. So our cast rule is telling us which things are positive. All of them in quadrant 1, positive. Quadrant 2, we have an S, only sine is positive in quadrant 2. Quadrant 3, we have a T, only tangent is positive in quadrant 3. And in quadrant 4, we have a C, saying only cosine is positive in quadrant 4. Okay, that is how reference angles help us. And we did questions like this in grade 11, where they would tell you something like, hey, cos of theta is -1/2. And you would say, oh, find theta between 0 and, this is a question from last year. Or last semester, depending on when you took grade 11 math. Find theta between 0 and 360 degrees. So the very first thing you would find is your reference angle. And you'd find your reference angle by doing cos inverse of +1/2. Because reference angles are always positive. And since reference angles are always positive, when you find them, you always plug in positive values to guarantee you get an answer in quadrant 1. We type this into our calculator and we find out that our reference angle is 60 degrees. Then we would say, but cos of theta was negative. So according to my cast rule, I'm looking for an answer either in quadrant 2 or in quadrant 4, because those are the two places that cos is negative. If I used my reference angle of 60, what's the answer in quadrant 2? Well, if I think quadrant 2 would be like 180 minus 60, my answer would be 120 degrees. In quadrant 3, if I think my reference angle is 60, I'd go 180 plus 60. My answer would be 240 degrees. So a little review of trigonometry in grade 11. Reference angles were really important in grade 11. So was the cast rule. We do that again with grade 12 trigonometry. Okay? We do almost all of grade 11 trigonometry again, with one main difference, is we switch the units we use. We're going to switch using degrees. Sometimes we'll still do degrees, but sometimes we'll use radians. So we're going to do these same kind of questions with different units. So if you remember all of your stuff from grade 11 trigonometry, you're just adding one new thing. If you've forgotten everything from grade 11, then you're adding a whole bunch of new things and one new thing. So, but we'll take time like this to review those processes as well. Okay, that is our second definition. Yesterday we started with angles in standard position. Now we've talked about reference angles, and it is the angle between the terminal arm and the nearest x-axis, and we always label a reference angle as positive. And our third definition that we're going to look at are coterminal angles, and this is actually an easy definition if you know how the English language works. This word has the word terminal in it with a co out in front. Okay? And I'll write the definition here. Two angles are coterminal if they, well, it's not quite a they, if they share the same terminal arm. There are a lot of English words that start with co, which kind of mean share things or a combination of things together, right? I play on a co-ed soccer team. There is cooperation, working together, something together. In this case, the thing that's together is the terminal arm. So an example, here are examples. If I pick 60 degrees, 60 degrees is coterminal with, I'll go backwards. Also in standard position, 60 degrees is this way, right? That's in standard position, 60 degrees. If I went backwards, can you see that negative 300 degrees ends in the exact same spot? So we would say 60 degrees is coterminal with 300 degrees. It's also coterminal with, I could start here and go all the way around and more. All the way around is 360 plus 60 more. This is 420 degrees. All three of those angles end at the same spot. And so if an angle ends at the same spot as something else, it's coterminal. It doesn't mean they're equal, right? It doesn't mean if I was competing in the Olympics and I went over a ski jump and stayed completely straight and landed, that it would be as amazing as the person that did the 1080 and landed, right? We're coterminal. I'm like, hey, we're coterminal. I should be in the Olympics. And they're like, no. Scary thing is I probably wouldn't land my 0 degree trick. There'd be snow plowing all the way down to the jump. Oh, you watch the ski jump? They have the camera. And I'm like, it's just scary enough when you're on a roller coaster and you're strapped in. They have that camera on that ski jump and it's just like, there are these ruts. You are in them. You are going. There's, can you, like, how would you bail? I don't know if there's any good thing to do. It's just like, I just watch that every night. I'm like, yeah, I'd die. Oh, next guy. Yep, I'd die again. Anyways. So coterminal doesn't mean that they're the same. It just means that they end in the same place. Okay? All right, so these are our definitions. The textbook has some of these definitions and some examples with them on page 468. So they start showing some angles in standard position on 468. They show an angle in standard position negative. They talk about, and you can highlight it if you want, textbook talks about coterminal angles and they give some examples. Look at all of these end in the same place. But interestingly, does it make sense? There are an infinite amount of angles that are coterminal with any given angle. And connecting to what we did before, we're going to now extend trigonometry beyond 360 degrees. Okay, so in grade 11, we went up to 360 degrees. But now in grade 12, I might ask you, what is sine of 380 degrees? And you would say, well, 380 degrees looks like this. And it's coterminal with 20 degrees. It has a reference angle of 20 degrees. It's in quadrant 1. So because it has the same reference angle as 20 degrees, and because it's in quadrant 1, I don't need my calculator. I know it's going to be 0.342, exactly the same as sine of 20 degrees. Okay? And we're going to get questions like this one in grade 11. from 0 to 360, but they might change the 360 to 720 degrees. And you'd have more answers. Because if you went around twice, you would hit another answer in quadrant 2 and another answer in quadrant 3. So you would have to add 480 degrees to your answer and 600 degrees to your answer. And sure enough, if you check, right? If I take out my calculator, this is kind of cool. Maybe, if it works. Right? I'm saying that if I went to 720 degrees, then 120 is coterminal with 480 degrees, and 240 is coterminal with 600 degrees. Can you see that all I did was add 360, which is one full circle around? If you're at 120 and you add 360, you're going to be back to where you started with. Right? And that's why I didn't do anything on my jump. I'm like, well, why would I do that 1080 if I'm going to just be back where I started? Don't need to impress anyone. But now if I go to my calculator and check this, make sure my calculator is in degrees, and I do cos of 600 degrees. Look at that. I get negative 0.5, which is what I had as my question to begin with. My question to begin with was, what values of theta, when I type them in, give me negative a half? Well, if we find a reference angle, we found 120 and 240, but now we find out 480 and 600 work as well. Does it make sense if you added 360 again, you'd end in the same spot? And so my guess is if I had 360, 960, should I try that on my calculator? Is cos of 960 also going to work and give me negative 0.5? It does. And now we move beyond. How many angles would be coterminal with 240 degrees? Infinitely many. You know what's coming? I'm going to ask you, list every single possible answer. All infinite amount of them. And you're like, oh, my last math assignment before I die. Because it's going to take me forever. And I'm going to die and I'm not going to finish. But we're going to find out how to write an infinite amount of answers. And we do it like this. So highlight one more thing here, then we'll get to our first example. Again, mathematicians are lazy. They don't want to write an infinite amount of things down. Someone figured out that that would take a very long time. So they're like, how can we write an infinite amount of things down without writing an infinite amount of things down? We do it like this. All the angles coterminal with 40 degrees, we would say, well, start with 40 degrees. Then this part right here says you can add or subtract 360 degrees as many times as you want, right? If you add 360 once, you get 400. If you add 360 twice, you get 760. You could add 360 again and get 1120. What this is saying is start with 40 degrees and add 360 degrees k times. And then you define k to be an integer. This is the mathematical symbol for integers. Integers are all your positive and negative whole numbers and 0. So if your integers are all your positive and negative whole numbers and 0, that means all of the ones coterminal. You could pick any of those numbers you wanted. You could add 360 8,000 times, because 8,000 is an integer. Or you could subtract it 32 times. You have every single number possible by saying k is an integer, and this is a way to write mathematically an infinite amount of answers without taking an infinite amount of time. It's like very efficient comparatively. Okay. Whoops. Whoops. Hit the wrong button. Way to go. Example. Here. Determine the measures of all the angles in standard position between negative 800 degrees and 800 degrees that are coterminal, in other words, end as the same place as 85. I'm going to draw 85 degrees right now here in blue. This is 85 degrees. Okay. So let's list all the coterminal angles with 85 degrees. And technically 85 degrees is one of them. Does 85 degrees end in the same spot as 85 degrees? Yes. It's kind of like, sometimes people leave it out because they're like, well, we're already set it. But technically 85 degrees is coterminal, ends in the same place as 85 degrees. If we're doing the positive direction first, this would be the second one. And how would I find that one? Well, I could go 85 and then add another 360, adding another 360, 445 degrees. And I could, I'll do it in purple. Woo! Go around twice. And that would add 360 degrees again, which would get me to 805 degrees. But that's, according to our question, I'll put an X through that one. That's too far. They just want all of the ones listed between negative 800 and 800 degrees. Ooh, so now let's go negative direction. So I'm going to start one in here in red. If I go in the negative direction to there, can you see that that would be like 85 subtracting 360? If I do that, I'm going to get negative. What is that going to be? 275 degrees. 385 minus 360. Sometimes I do it the other way. I do 360 minus 85, get the answer, and then just add a negative in front of it, because it makes my mental math a little bit easier. And we've got another one here where we could start here, all the way around once, all the way around again. If I subtract 360 off of this one again, I'm going to get the orange, negative 635 degrees. Can you see that if you subtracted 360 again, that you would go past negative 180? So this would be the answers of all the angles that are coterminal. In part B, if you wanted to write an expression for all the angles that are coterminal, we could start with our There we go, I'll write it out. This is going to be an infinite amount of them. All coterminal angles, you would start with your 85 degrees, and then you would add 360 degrees k times, and define that k has to be an element of the integers. So that would also include angles like this one. Ooh, ooh, ooh. And any other ones. Yes.
It doesn't matter where we multiply, like what side the k is multiplied on. Because...
No, you can put the k in front or the k after.
Okay.
Did they have it in front before?
Yeah.
Yeah. Seems like in degrees they like to put it in front. When we do radians, they like to put it in the back. But it really doesn't matter. But you do need the degree sign. Now something you might not have noticed while I was doing all of these spirals is that all those spirals, they just put you into like a hypnotic state. Don't worry, I can get you out of it. But you are currently, by watching this, unbeknownst to you, you are now in a state of hypnosis. I'm gonna clap my hands later. You're gonna pull out of it. It's gonna be all good. But just since you're in this state right now, I could do some influential things that can like really help you in this course. So like tomorrow or tonight, you're gonna get home from school, and it's gonna be weird, but you're like, huh. You're gonna feel like doing some math homework. You won't know why, but it'll just be like all of a sudden you're gonna feel that. And you'll be like, I like math. Okay? Now you won't remember any of this after I clap my hands. You'll be popped out of your hypnosis state. But this is gonna happen to you tonight, sometime in the evening. You're gonna be like, oh, I like math. I feel like maybe I should do some math. All right. Okay. Okay, so questions that you can circle on this one, 4 and 5.